Hi there, welcome back to Priya's math classes. And in this video, I will talk about relationship between roots and coefficients of a quadratic equation. In my previous classes, I discussed the methods to solve the quadratic equations. And in this video, I will explain to you the relationship between the roots and the coefficients. So let me consider my quadratic equation ax square plus bx plus c is equal to 0. It is in the standard form, of course, okay? And the coefficient of x square is a, coefficient of x is b, and c is the constant, of course. So a quadratic equation will have how many roots? 2 roots, right? We have seen this earlier. So let me say alpha and beta are the roots, okay? Alpha and beta, it will have 2 roots, and alpha and beta, they could be same, identical, or they could be the different, real and different, real and equal, real and identical, or they could be imaginary. Okay, that we shall see eventually. For now, let's see the relationship. So we need to see how alpha, beta, the roots, and the coefficients a, b, c are related. Simple. Sum of the roots, if I were to say sum is s, sum is equal to what? Alpha plus beta. I'm just adding these 2 roots. The sum of the root is equal to minus of b by a, and the product alpha into beta is c by a. This b from here and this c from here, okay, and by a. So alpha plus beta product is, let me say it's p. Product p. Okay, p is alpha into beta, which is c by a. Right, it's a very beautiful relationship between the sum and the roots and product and the roots. And let's try to verify. Verify as in, let me take an example. I just don't want ABC. Okay, let me take proper numbers, real numbers. X square minus 5x plus 6. A very old famous example. All right. So we have seen this earlier, right? What are the roots? Alpha is 3. Beta is 2. 3 and 2 are the roots. And addition and multiplication, both are commutative. So it doesn't matter. I could, even say beta is 3 and alpha is 2. It doesn't matter which order you take it. Just call them, give them names, alpha and beta. This is alpha, this is the symbol for beta. Basically, they are Greek alphabets. Let's not go into that. Now here. So what's 3 plus 2? 3 plus 2 is my alpha plus beta, right? It's the sum. Sum of the roots is alpha plus beta, which is 3 plus 2, which is 5. Alright. And let me look at what is minus b by a. What's my b? My b, when I compare it with the standard form, my b is minus 5. Okay, let me put that down here for you. A is 1 and b is minus 5 and c is equal to 6, right? So alpha plus beta is 5, minus b by a would be minus b is minus 5 divided by a is 1, minus of minus 5 divided by 1 is plus 5. Coming back here, it is c by a. C by a is, what is c? 6 by 1, which is 6. What's my product? Product is alpha into beta. Alright. What did I say my alpha is? My alpha is 3 into 2, which is 6. See, there you go. Alpha into beta is equal to c by a, c divided by a, and alpha plus beta is minus b by a. Alright. So we derive 2 important results here. If my sum, what is sum? Alpha plus beta, right? Where is that? Yeah, here. Sum is alpha plus beta. And if my product p is alpha into beta. When s and p are known, when the sum and the product are known, it's simple. If they were to ask you, find a quadratic with sum as this and product as this. In this case, find a quadratic equation with the sum is equal to what? Let's say the sum of the roots is given as 5 and product is given as 6. My sum is, let's say, 5 and product is 6. The simple equation that we have is x square minus sum into x plus product is equal to 0. So there you go, your equation. X square minus 5x plus 6 is equal to 0. Alright, and if my sum and product are not given, rather alpha and beta are given, alpha is 3 and beta is 2, then you could frame your quadratic as x minus 3 into x minus 2 is equal to 0. Generalized, it is x minus alpha into x minus beta is equal to 0. So, if the sum and the product are given, use this equation, general form, x square minus sum into x plus product is equal to 0. And if the roots, the actual roots are given, if the actual roots are given, then you just have to use this x minus alpha, which is one of the roots, into x minus beta is equal to 0. Alright, and when you expand this, you would actually get x square minus alpha plus beta into x plus alpha into beta is equal to, so there you go, it just boils down to the same thing, okay. I hope this is clear. We'll see more practice, and we'll also see nature of the roots in my next session. Alright, take care.